Hello my dear students, welcome back to Learn Physics. In today's topic, we are going to discuss about the electrostatics chapter, part 3. In part 1 and part 2 also we discussed the same unit only, but in today's video we are starting the second chapter, that is electrostatic potential. So first we will go through the theory portions once more. Electrostatic potential. What is meant by electrostatic potential? It is defined as the minimum work required to be done by an external force in moving a test charge from one point to another. How much minimum work is required to move a test charge from one point to another? That is electrostatic potential. And what is the formula for finding out the electrostatic potential? Work done with a unit test charge. So W by Q, that is called a electrostatic potential. Now, what will be the unit of this electrostatic potential? Its unit is volt, or we can write it as work done unit is joule, right? So it is joule per coulomb also we can write out. Or see, work done, how we will find out force into displacement. So it is another unit is, instead of joule we can write it as Newton meter, right? So Newton meter per coulomb also we can write down for the electrostatic potential. So next is electrostatic potential at any point is minimum work done in carrying a unit charge from infinity to that point. Work done in moving a unit positive charge over a closed path in an electric field is zero. So we know it is electrostatic potential is conservative. So work done in moving a unit test charge in a closed path, that is initial position and final position will be same for a closed path. So their work done will be equal to 0. Now, electrostatic field is conservative field. That means it is depending on only on the initial and final position, not on the path which they are taken. Next is, what is the electrostatic potential due to a point charge? Formula for finding out the electrostatic potential due to a point charge, V equals 1 by 4 pi epsilon 0 Q by R. What will be the electrostatic potential at infinity? Because if we are substituting the value of R as infinity, because we need to find out the electrostatic potential at infinity, right? So here, if we are substituting R as 0, what will be the value? 1 by infinity equals 0. So potential will be equal to 0. Next is electrostatic potential at a point due to an electric dipole. In an electric dipole, how much will be the electrostatic potential? All these things, detailed theory we did our theory portion. That is, in that playlist you can see all the theory portion with the detailed explanation. Here I am giving only the formulas. V equals 1 by 4 pi epsilon 0 P cos theta by R square. Next is equipotential surface. Equipotential surface is that surface at every point of which electric potential is same. Electric potential is same at that equipotential. Potential is same at that surface. And now we are checking what are the properties of these equipotential surface. No work is done in moving the test charge from one point of equipotential surface to the other. Right, work done will be 0. What is the reason? Because it's same potential. Potential difference is called the work done, right? So this potential difference per unit area. So work done per unit area is the potential difference. But if potential difference is 0, because same potential everywhere. If potential is same everywhere, what will be the potential difference? That will be 0. So work done will be equal to 0. Next point is electric field is always perpendicular to the equipotential surface. That also very important point. No two equipotential surfaces intersect each other. Equipotential surfaces are closer in regions of strong electric field and they are far apart in the regions of weak electric field. Okay, so these are the important points for the equipotential surfaces. Now we will check the 1 mark questions. First question, express the unit of electric potential in terms of the base units of SI. In base units of SI, how we can convert this electric potential. So we are telling it as joule per coulomb like that. Not joule is not the base unit, right? It is a derived unit. So in terms of base units, how we can do? Electric potential, what is the formula? Work done divided by charge. First, we are finding out the dimensional formula for electric potential. So, dimensional formula anyway we will be getting in terms of base units, right? So, see n L square t to the power minus 3 a to the power minus 1. So, what will be the SI unit? Instead of mass, kilogram, L meter, t second, a only, right? So, we will be getting the in terms of base units, we will get the electric potential. Next question is, a point charge Q is placed at point O as shown in figure. Is the potential difference VA minus VB positive, negative or 0 if Q is positive, second one negative. So here Q is placed over here. We need to find out the potential difference VA minus VB. Okay, if Q is positive, what will be VA minus VB? If Q is negative, what will be VA minus VB? How we can find out VA minus VB? What is the formula VA? Due to potential at A due to the charge Q, 1 by 4 pi epsilon 0 Q by this distance, that is Q by OA. Here I have given K as 1 by 4 pi epsilon 0. Instead of 1 by 4 pi epsilon 0, I have given the value K, KQ by OA. 1 by 4 pi epsilon 0, Q divided by distance OA minus, what is the potential difference at B? 1 by 4 pi epsilon 0, Q divided by OB. Now, this is the formula. Now, if Q is positive, what will happen? 1 by OA. OA is lesser than OB, right? Then what will be 1 by OA? 1 by OA will be greater than 1 by OB. If Q is positive, VA minus VB will be positive. Then tell me if Q is negative, what will happen? 1 by OA minus 1 by OB, that is VA minus VB will be negative. Clear? So since OA is less, 1 by OA will be greater than 1 by OB. Larger value minus smaller value will give you a positive value. So if Q is positive, VA minus VB will be positive. If Q is negative, VA minus VB will be negative value. Clear? Next question. The electrostatic field due to a point charge depends on the distance r as 1 by r square. E is equal to 1 by 4 pi epsilon 0 q by r square, right? Similarly, indicate how each of the following quantities depends on r. Intensity of light from a point source. That is the first one. Intensity of light from the point source, how it is, intensity is depending on the inverse square law. So it is inversely proportional to R square. Next is electrostatic potential due to a point charge. Due to point charge 1 by 4 pi epsilon 0 Q by R. So it is inversely proportional to R. Now, electrostatic potential at a distance r from the center of a charged metallic sphere of radius capital R. So, charge is distributed at the surface of the sphere, right? So, inside that, what will be the charge? at a distance r, there is no potential won't be present over there, right? So here, in case of a charged conducting sphere, for an internal point, potential will be a constant. That is, what will be the potential at the surface? That will be equal to inside also same way. It's no difference. What is the reason? V is depending on the surface. V is present only at the surface, and the inside also same way. From the charged sphere, it's outside while we are considering, potential will be varying. Okay, in the case of a charged conducting sphere, in all the internal points, the potential difference will be, or electrostatic potential will be same at the surface. V is not depending on the internal points. Clear? So this is some of the questions based on this electrostatic potential. So the next video also we will be discussing the same topic only. So be thorough with us. While I am reading the question, just please pause the video and try to solve the answers and then check the answer whether it is clear or not. Okay. So I think this video is useful for you, and if you like the channel, please don't forget to subscribe, like and share. Thank you for watching. Bye.